This recorded video utilizes our solution to generate subtitles in real time.
就是以前我可能只负责前台，那我现在可以看到后台，我觉得这是一个非常难得的机会。你可以学习到高科技公司他们到底是怎么做事的，可以应付成千上百万的客户在这样的一个使用。
Let me walk you through how we build this solution. First, we check the nodes running in our EKS cluster. Then we can see a carpenter is up running with node pool with GPU resources. Next, we look at the kube-ray operator that manages ray cluster handling the inference tasks. Now we just need to apply the YAML file which defines our application. We already applied it before recording this demo. We can see the ray cluster head port is running. It distributes incoming requests to worker port with GPU. Let's check the ray service here. The kind is called ray service. We specify some containers. The ray head port exposes port 8000 for WebSocket, which is an interface to receive audio streaming. This port only requires CPU. Let's take a look at a worker group. It requires a GPU to handle the requests. The processing involves 3 stages that can scale separately. The first one is transcription server, receiving incoming audio files and passes them to next stage. It could scale up to 5 replicas to support 100 concurrent queries. The second stage is voice detection deployment to analyze the audio. The third stage is using a whisper speech recognition model, returning generated transcription back to transcription server. The system shows a running state, meaning it's ready for requests. Now let's run a command to list all the nodes of an EKS cluster. The node with the label initialized to means they were provisioned by Carpenter to handle the incoming requests. G5X large instance comes with GPU resources. Let's get the port forwarding running. We use port 8265 for ray dashboard and also port 8000 for WebSocket. Let's open the client. This is the interface we are going to use to connect to the WebSocket exposed by port 8000. You can see WebSocket is connected. I will start streaming and read some text here. In this post, we described how to build a scalable and distributed ML inference solution using the WISP model for streaming audio transcription, deployed on Amazon EKS and using Reserve. Let's switch to a different language using manual here. 无论您是需要计算能力、存储、内容分发，还是其他的功能，AWS 都能提供所需服务，方便您构建极为复杂的应用程序。Here we go, Mandarin showing up here. Okay, next, let's see how the environment scale to deal with increased workload. We use a tool called Locust to simulate some traffic. Let's just open up that tool. And we add it to set up 20 concurrent users to connect to this environment at a time. WebSocket connection is going up until 20. Let's look at command line. One additional pod has been initiated. It's in pending state, means it still waits underlying compute. The new instance is being provisioned, however, it's not ready yet. Let's look at the RAID dashboard. So only one worker pod is handling the increased requests, and GPU is 92% utilized. So we have a new pod up running now. It takes some time to load the 10 gig container image, which hosts ML models. Now we have 2 more additional worker pod running. Let's continue increasing the load. Concurrent users are increased to 40. We have more pods provisioning, and nodes is handling the on-demand requests. It takes some time, so I fast forward the video. So we load many container images here, so lots of pods running, and all the load has been distributed evenly. Then we'll stop testing. No load, the pod will be terminated automatically. So Sona, the carpenter, deleted idle nodes because there's no demand here. The log files, let's look at the logs. Here we go. Some nodes has been deleted. So that's end of demo.